Hi, Math 3 students. So we're going to go ahead and do the worksheet on solving rational equations. This is posted on Canvas. Those of you who were in person should have the worksheet, so you could grab that. If not, feel free to print it off of Canvas or just do it on notebook paper. All right, so let's go ahead and try and solve this first one here. So essentially, solving rational equations is very similar to trying to solve or trying to simplify by adding and subtracting, right? When you add and subtract fractions, you need to get a common denominator, and that's exactly what we're going to have to do here. So let's kind of look. We could look at this 6k squared. So let's break down 6. We're going to go ahead and just factor these down to their prime factorizations here. 6 is the same as 2 times 3, right? Then we got k times k. Then we've got 1 all over 3 times k minus 1 over k. So basically what we have to do is we have to try and get a common denominator here. So if I look, this guy has everything. There's nothing that the other guys have that he doesn't have. He's got a 2, 3, and a k and a k. This second guy, though, he's missing a 2. So we're going to multiply him by 2. So we've got 1 over 3k squared, and we're going to multiply him by 2 over 2. All right, then we're going to go ahead, I guess actually we could do that, and we get 2 over 6k squared. This other guy's going to stay the same. We've got 1 over k squared, or 6k squared, sorry. And now if we look at this 1 over k, he's missing a k, a 2, and a 3, right? So we're going to multiply him by 2 times 2 times 3 times k, all over 2 times 3 times k. Which is going to give you a 6k on top and a 6k squared on the bottom. All right, so now, if you look, we have common denominators across this entire equation here. So what we can do, once you get a common denominator, this is so important, you have to have a common denominator to do this, you can get rid of your denominator. So we end up with 1 equals 2 minus 6k. All right, now it's a super duper easy equation. We're just going to do minus 2 minus 2. We get negative 1 equals negative 6k divided by negative 6, and we get k is equal to 1/6. All right, so let's just kind of backtrack, talk about what we did here. We have to have a common denominator across all of the terms in order to be able to drop out the denominator. All right, so that's how we do problems like that. Now, one thing I want to point out, there is something called extraneous solutions. And what that means is you'll get something like, oh, k equals whatever, but it actually isn't a solution. And basically that happens when the number that you get causes a 0 in the denominator. So if you look here, if we had gotten the k equals 0, we would have ended up with 1 over 0, right? That would have been a problem. That would have been an extraneous solution. But that didn't happen, so we're good. All right, so let's go ahead. Let's try this one. All right. So we're looking here, and we need to factor everything. So that's going to be our first step. Let's go ahead and factor everything we got here. So if I look at my denominator, I can take an m out. So I'm going to have 1 over m minus 1 plus, and then this guy's can't do anything, so we've got 1 over m equals 5 over m times m minus 1. So again, we still got to do that factoring. Don't forget factoring, so important. So we're looking, all right, we got these guys are the same. All right, and this guy's real close. He's just missing the m minus 1. So we're going to take him 1 over m, and we're going to multiply him by the m minus 1. All right, and when we do that, this guy's going to stay the same. We get m times m minus 1 plus, and keep in mind you're supposed to distribute this, right? So you would get m minus 1 all over m times m minus 1 equals 5 over m times m minus 1. All right? So now we've got common denominators. We can get rid of that denominator. We get 1 plus m minus 1 equals 5. So these guys are going to cancel, and you're just left with m equals 5. All right, and then you do need to check if I plug in m equals 5 into any of these denominators, am I going to get a 0, right? So essentially plugging in a 1 or a 0 is going to give you a 0 on the bottom. So if you take your common, basically what you're going to want to do is take your common denominator, which in this case was m times m minus 1, and set it equal to 0. So basically m equals 0, m minus 1 equals 0, m cannot equal 0, and m cannot equal 1. So those would be the bad solutions. We didn't get that, so we're good to go. Our answer's good. All right. Let's go ahead and try another one. Let's see. Let's try number 13. I feel like this one will be a little bit tricky. So we look. We got to try and get common denominators here. So we look, and I'm like, okay, this guy's got a 3x, this guy's got a 3x, this guy needs a 3x. So even if something's not a fraction, you could always turn whatever you want into a fraction. You just put it over 1. So we're going to multiply that by 3x over 3x. We end up with 3x, over 3x plus x squared minus 5x minus 24 all over 3x equals x minus 6 all over 3x. Now, we've got a common denominator across the board here, so we can drop that out. And we get 3x plus x squared minus 5x minus 24 equals x minus 6. All right, so at this point, I can see that I'm going to have a quadratic. So I'm probably going to want to get everything on the same side here. So first, let's combine like terms. We can combine this 3x and negative 5x. So we have x squared minus 2x minus 24 equals x minus 6. Let's bring this x over. X squared minus 3x minus 24 equals negative 6. And then bring this 6 over. We get x squared minus 3x minus 18 equals 0. So once you get this equals 0, you could go ahead and either use quadratic formula, or you could factor. You guys hopefully remember doing this with polynomials, right, to solve equations. For this one, I'm going to try and factor here. I think that's best. So I want you guys to factor this for me. Factor x squared minus 3x minus 18. So when you do that, you should get x minus 6x plus 3, which when you solve, you get x equals 6, x equals negative 3. And we have to make sure, okay, are both of these solutions good? So we're going to go to our common denominator here, which is 3x, set it equal to 0. We get that x cannot equal 0. So these solutions are good, and we are good to go. Let's go ahead and do at least one more here. Let's see. Let's try number 19. That one looks tricky. All right. So again, we need a factor. We got so much factoring we got to do here. So let's factor this denominator here. So we got p plus 5 all over, and I'm going to take a p out. So I get p plus 1 equals 1 over, and again, we can take a p out. So we get p times p plus 1 minus, and then we got p minus 6 all over p plus 1. So looking at these denominators, it's just the only thing we need to kind of fix here is this last guy. He's missing a p. So we're going to take him. Oops, actually, let me do that. We've got p minus 6 all over p plus 1, and we're going to multiply him by p over p because he's just missing a p. All right, now this is kind of tricky. You have to make sure that when you multiply, you distribute on the top there. All right, so we would end up with p squared minus 6p all over, and we've got p times p plus 1. And then we've got all this other stuff we had originally, which was 1 over p squared plus p equals p plus 5 all over p squared plus p. Oh, actually, I should have left this factored. Sorry. P times p plus 1, p times p plus 1. All right. So now we've got a common denominator, so we are good to go. We can get rid of our denominator. So we've got p plus 5 equals 1 minus, and notice we have to distribute this. So actually, I guess we could just do that now when we rewrite it. We would get minus p squared plus 6p. That's super important. You have to distribute it to each term when you have that subtraction sign. So now let's go ahead. I'm going to get everything over on this side of the equation. So let's go ahead. We'll do minus 1. Minus 1, we get p plus 4 equals negative p squared plus 6p. I'm going to add p squared. We get p squared plus p plus 4 equals 6p minus 6p. We get p squared minus 5p plus 4. All right, and that's equals 0. So now we can go ahead and to solve, again, we can factor this. So I want you guys to go ahead and factor this for me. So when we factor, we should get p minus 4, p minus 1 equals 0. So we get p minus 4 equals 0. P minus 1 equals 0, so we get p equals 4, and p equals 1. Oh, sorry, and then we got to check, do our solutions work, right? So we have p times p plus 1 equals 0. We get the p cannot equal 0, and p cannot equal negative 1. Both of these check out. We're good to go. All right, I know we're going out of order, but let's go ahead. Let's pop back to number 18. Sorry, guys. So, again, we have to try and get a common denominator. So this first guy has an a plus 3. All right, so I'm looking here. Well, what is he missing? He's missing the a plus 2. So we're going to multiply this guy, a minus 2, all over a plus 3. And we're going to multiply him by a plus 2. All right, and when I do that, if you recall, we have to FOIL this. All right, so I'm going to go ahead and get an a squared. Actually, I'll just FOIL this up here so everyone can see. So you have a minus 2 times a plus 2. All right, so we get a squared plus 2a minus 2a minus 4. These cancel, and you end up with a squared minus 4 on top. So after we multiply, on top we get a squared minus 4, and on bottom we've got a plus 3 times a plus 2. All right, so now we got to look at this other guy. What is this guy missing? Well, he's missing everything that could possibly be in the denominator. This guy has an a plus 3, and this guy has an a plus 2, so he needs both. All right, so we're going to take our 1 here, and we can turn him into a fraction. And let's go ahead. We're going to multiply him by a plus 3 and a plus 2 on top and bottom. All right, now again, you have to FOIL on top, right? So I'll go ahead. We'll do the work up here. A plus 3 times a plus 2. We get a squared plus 2a plus 3a plus 6, which is going to give us a squared plus 5a plus 6. So we get minus, ooh, I should leave that in blue. We get minus a squared plus 5a plus 6 all over our common denominator of a plus 3 times a plus 2. So we're almost there, guys. Now we got to try and get this 3 over a plus 2 to have the common denominator. What do I need to multiply this guy by to get a common denominator of a plus 3, a plus 2? What am I going to multiply this fraction by? I'm going to go ahead and multiply it by a plus 3. That's what it's missing, right? And keep in mind, you either have to FOIL, distribute, whatever on top. So we're going to have to go ahead and distribute this. And we get that this equals 3a plus 9 all over a plus 2, a plus 3, just like we wanted. All right, so we're making good progress here, people. We can go ahead now and drop out our denominator. So we'll go ahead and rewrite this. We've got this guy first, which is a squared minus 4. Then, remember, this is subtraction, so we're going to have to go ahead and distribute this negative. We get minus a squared minus 5a minus 6. And then we're going to set this equal to 3a plus 9. So what ends up happening is these a squares cancel, which is pretty snazzy. And we end up with minus 5a. We can combine these guys. We get a minus 10 equals 3a plus 9. Go ahead, we'll do minus 3a. Minus 3a, we get 8a. I'm sorry, negative 8a. Minus 10 equals 9. Add 10. We get negative 8a equals 19. We divide by negative 8, and we get a equals negative 19/8. And of course, we got to see, well, what values don't work here? A plus 3 times a plus 2 equals 0. That was supposed to be a 3. Basically, we get that a cannot equal 3, and a cannot equal negative 3, and a cannot equal negative 2. So our answer checks out. We like our solution.